A wind turbine slows air with a density of 1.25 kilograms per cubic meter from 7.12 to 6.5 and needs to capture this much power, right? What radius does it need to be? How many of these would you need to capture 120 megawatts? Okay, let's see. Okay, let's figure out the radius, right? So if you've got two different velocities, right, the power of a wind turbine is 1/2 the area, the density, times the velocity to the third. That's the power available to it. If it's the air comes in at one speed and goes out at another speed, right, in minus out, right, assuming that it's, not speeding up the air, right? Okay, so we can figure out this. We know that it needs to be 126.5 kilowatts. So 26.5 times 10 to the third is 1/2 times pi times r squared, and that's what we're trying to solve for, right? Times 1.25 times 7.12 to the third minus 6.50. Okay, I think we can solve this for r. So I'm going to go 26.5 E3. Okay, divide by 0.5, divide by pi, divide by 1.25, divide by left parenthesis 7.12 to the third minus 6.5 to the third. And I get r squared is 156, so raise that to the 0.5. And I get 12.5, so I get radius is okay. So now we got to figure out how many of those to make 1.2 megawatts, right? Well, each one's 26.5 kilowatts, right? So all we have to do, the number is just going to be the amount we need. So 1.2 times 10 to the 6, that's a megawatt, right? Divided by 26.5. Right, and that's total, right? And this is watts per turbine. So we'll end up with number of turbines, right? So let's go 1.2 E6 divided by 26.5 E3. And I get 45.28. So 45 is the closest to that power, but if you need that much power, and it can't be less than that, then you'd need 46 of them. 45. Just depends, just look at the wording, right? If you need at least that much of it, about that much, 45 is the right answer. At least that much, 46 is the right answer.